Hey everybody. In class today we worked on the properties of inequality. Tonight we're going to use those properties of inequality to solve inequality statements. Inequalities are important because they can help us represent situations in a way that's more descriptive than just an equation. Our first problem here is a good example of that. Aaron wants to buy chips from the store and has $17.50 to spend. If each bag of chips costs $1.25, how many bags could he buy? Now, there's a lot of different answers to this question. If we wrote an equation like 1.25 times b equals 17.50, this would just give us one answer, okay? Because it's an equation, it can only have one solution. But if we write an inequality for this statement, we can actually get a bunch of different answers, right? He could buy 0 bags. He could buy 1 bag. He could buy 2 bags. He could buy 3 bags. We want to know what are the different numbers that he could buy. So first thing we want to do is underline the question that we're looking for. How many bags could he buy? So we can use b to represent that. B equals the number of bags. Remember, setting up our variable right away makes things a lot easier when it comes to setting up our statement. Now, I know he has $17.50 to spend, and each bag of chips costs $1.25. I'm going to put a box around those two numbers because those are important. Now, I know that because each bag costs $1.25, I'm going to multiply that by the number of bags, which is b. Now, he could spend all of his money. He could spend less money than he has. He could use some of that money for something else, like something to drink. So it's not going to be 1.25b is equal to 17.5. It's going to be 1.25 times b is less than or equal to 17.5 because this is the amount he's going to spend. The amount he's going to spend has to be less than or equal to the amount of money that he has. Now that we have this inequality written out, we can go ahead and solve it. Draw a line through my inequality symbol just like I would through my equal sign if I was solving an equation. And we do the exact same thing we would do to solve an equation. 1.25 times b is less than or equal to 17.5. I'm going to divide by 1.25. Because we have multiplication going on right here, I'm going to use division because it's the inverse operation. So we're still using inverse operations. I'm going to divide over here by 1.25. Now, 1.25 divided by 1.25, that's 1. Those cancel, and we have b is less than or equal to 14 is what we get over here. So this is the answer to our question. b is less than or equal to 14. Now, when we solve an inequality, we also want to graph that inequality. So you can draw a number line. I like to have 3 numbers on it. I can go 0, we're going up to 14. I'm going to count by 7s. And we got 14. You know, we can also put another one. We can put 21 there if we want. And now b is less than or equal to 14. To graph that, I'm going to use a closed circle because it could be equal to 14. And I'm going to graph my answer going to the left here. Okay, b is less than or equal to 14. Just like we saw in the last problem, to solve an inequality, we use the same steps we would use to solve an equation, except there's one big exception. If we multiply or divide by a negative number while we're solving the inequality, you must flip the inequality symbol. Okay? In these two examples here, we're just going to go through, we're going to solve them like we would solve an equation, and if we have to, if we divide or multiply by a negative number, we will flip the inequality symbol. So let's look at our first example here. A plus 4 is less than or equal to negative 9. We'll draw our line down. Now a plus 4, to undo that plus 4, we're going to subtract 4. Inverse operations. We get a is less than or equal to negative 13. Negative 9 minus 4 gives us negative 13. Now, this stays less than or equal to because all we did was subtract 4. We did not multiply or divide by a negative number. Okay? In our next example, negative 3 times c is greater than negative 15. In this case, we draw a line through the inequality, the greater than symbol. Now negative 3 times c, we have to do the inverse operation of multiplication, is divide. So we divide by negative 3. Now, in this case, because we are dividing by this negative 3 right here, we are going to have to flip the inequality. Negative 3 divided by negative 3 is 1 on the left side. That leaves us with c. Negative 15 divided by negative 3 is positive 5. And that inequality symbol needs to flip. We get c is less than 5. All right, we're going to do 4 more quick examples just to really get the hang of this, and then we'll be done. First thing we have here is x minus 4 is greater than or equal to negative 1. So we'll draw our line. Now, inverse operation here is going to be addition. Since this is a subtraction problem, we're going to add 4. Same way we would solve an equation. This gives us x, because negative 4 plus 4 is 0, is greater than negative 1 plus 4 gives us 3. In our next equation, m divided by negative 5 is greater than negative 2. Because it's m divided by negative 5, we're going to use multiplication times negative 5 times negative 5. Now, the multiplication and the division cancel out. On the left side, we have m. Negative 2 times negative 5 is positive 10. But because we multiplied by this negative 5, this inequality symbol flips. And instead of greater than, it becomes less than. M is less than 10. In our third example, p divided by 2 is less than 5. Because this is division, we're going to use multiplication again. But here we're multiplying by a positive number. So we're still going to get p on the left side. We're going to get negative 10 on the right side, negative 5 times positive 2. But because we multiplied by this positive number, this inequality symbol doesn't change. It's still less than. Even though there's a negative involved, right? Negative 5, the answer is negative 10. So there's negatives, but we multiplied both sides by a positive number. So because that 2 is positive, inequality doesn't change. In our last example here, this one looks a little tricky. Negative n is less than or equal to 6. Remember, we can think of this as being negative 1n. Negative 1 times n is the same as negative n. So to get rid of that negative 1, we're going to divide by negative 1 on both sides. So we get n over here. 6 divided by negative 1 is negative 6. And because we divided by this negative number here, we divided by negative 1, we have to flip the inequality so it becomes n is greater than or equal to negative 6. So that's all of our examples for today. That's it. I will see you guys in class tomorrow. Have a good night.